Page 153, number 18. A conical tank with vertex down is 10 feet across at the top and 12 feet deep. That would make the radius 5. Water is flowing into the tank at a rate of 10 cubic feet per minute. That's the rate that the volume is changing. Find the rate of change of the depth of the water. I'll let the depth of the water be h. So that would be dH over dt. That's what we're looking for when the water is 8 feet deep. So if we're putting water into the tank, then this triangle formed here is H and R. And the big triangle is 5 and 12. So this turquoise triangle of water is R and H. So I have similar triangles. I can set up a proportion of the sides. Lots of different ways you can do that. But I could do R is to H as 5 is to 12. The formula for the volume of a cone, 1/3 pi r squared h. We're asked about the rate of change of the height, and we're given height. So we do not want the radius in the equation. So we use this information here, cross multiply. So that we can replace the radius with an h. So my volume equation becomes replacing the r with 5/12 h. And then simplifying would be 25 pi and 3 times 12 times 12 in the denominator. And I'm not going to multiply it out so that I can maybe reduce later. Now I need to take the derivative with respect to time. Implicit differentiation. This 3 is going to reduce with this 3. So this would be 25 pi over 12 times 12 h squared dH dt. And now I'm ready to plug in numbers. dV over dt is 10. H is 8. So I squared it. And I'm looking for dH over dt. So I'm going to multiply both sides by the reciprocal. So in the denominator, I will have a 25 and a pi and a 64. And in the numerator, I'll have a 12 and a 12. So dH over dt, let's see what we can reduce. The 25 and the 10, 2 and 5. The 2 and the 64, 1 and 32. The 12 and the 32 could reduce by 4, and that'd be 3 and 8. The other 12 could reduce by 4 with the 8, and that would be 3 and 2. And it looks like that's it. So it looks like 9 over 10 pi. The units for height is feet. The units for time is minutes.